Okay, we are back. Error handling. So, yeah, it's very important because I got lots of error all the time. And how to handle error in Rust is gonna be cool. So yeah, first of all, don't think I have much time to stream today. I would probably only be able to go through chapter 9 at most because I have a lot of other things to do today. So I'm sorry. I would catch up later if I have time. But so today we're gonna go through the error handling. So it's a fact of life. Yeah. So we can. Okay, so recoverable, unrecoverable error. A recoverable error. So file not found error. Yeah. So those are kind of so yeah, it's not fatal. So it won't like just stop the whole thing. It will report the problem and then retry. Unrecoverable is a bug. Yeah. Then we have to stop the program. Otherwise, consequences. Um, yeah. So yeah, there are other languages to handle this error in the same way, such exceptions. That's Python. So in Python, you can try and then accept, and then yeah, you can throw in an exception and then continue, or you can just have an exception and the whole thing crush. So yeah, yeah. So you can handle it differently in Python. So like yeah, you can use a try and then okay, life go on as normal, or you can just you know stop the whole program. But Rust don't have exceptions. So it has the type result. I think we have seen this in chapter 1 or 2 or something like that, for recoverable errors and panic macro that stop the execution. So when you panic, you stop everything. Yeah, so that's for unrecoverable error. So we'll cover panic and then talk about result. Yeah, whether to try to recover it or not. Okay. Unrecoverable error with panic. So sometimes bad things happen in your code, and there's nothing you can do about it. You can only stop. So use the panic macro. Two ways to cause a panic: taking an action that causes our code to panic. Yeah, either you do something very wrong, then probably, Rust will have something there to panic already, or you call panic to raise the problem, to say stop. In both cases, we use panic. We'll print a failure message, unwind, clean up the stack, and then quit. So that's how it got terminated. By environment variable, you can also have Rust display the core stack when a panic occurred to make it easier to trace down the problem. So unwind the stack or absorb in response to a panic. So when panic occurs, the program starts unwinding, which means that Rust will walk back up the stack and clean up the data to just tidy up and shut down from each function it encounters. However, this walking back and cleanup is a lot of work. Rust therefore allow you to choose the alternative of immediately aborting, which ends the program without cleaning up. Memory that program was using will then be cleaned up by the operating system. So yeah, usually operating system, when you killed a process, it will also clean up all the memory. So yeah, because otherwise, what else you can do? You have to reboot your computer, which is very bad. So yeah, operating system will also do the cleanup for you if you terminate a process. So if in your project you need to make the resulting binary as small as possible, you can switch from unwinding to aborting upon panic by adding panic equals to abort to the appropriate profile section in your cargo file. So in that way, then when the compiler is building the binary, then it will use this strategy. When panicked, then we just stop. So that would make the binary smaller. So yeah, profile.release is abort. So, panic, crush and burn. It will panic and burn. Yes. Yep. Panic at crush and burn. Yep. When you run the program, you see, yeah, exactly. The call to panic caused the error message to contained in the last two lines. The first line show panic message and place in our source code where the panic occurs. So we will see that, yeah, it's running this and then panic at here, and then it will show you where as well. Indicate that the fifth character, yeah, so it's here, it in here, the panic, right? So maybe in the code that our code core and the file name and the line number reported by the error message will be someone else code, not the line of our code. So sometimes it's someone else code because it's someone else code that caused the panic. Use the backtrace. Then you have to look at the backtrace to see what we have done. Go from figure out what part is causing, and we'll talk about the backtrace, which is a very useful thing. Yeah. So, for example, doing this, of course, the vector doesn't have 99, like 100 things, so it doesn't have the index 99. So this, of course, will panic. And we see that index out of bounds, the length is 3 but the index is 99, and then we see that is still say that is here, you know, it's 4, so here 4, 1 2 3 4, and then this one here. Okay, yep. So in C, attempting to read beyond is undefined behavior. You may get whatever that is located in memory would correspond to that element in the data structure, even though the memory doesn't belong to the structure. So you can get some random thing, which is not very safe because it may be someone else's memory. Got a buffer overload and can lead to security vulnerability if the attacker is able to manipulate the index in such a way to read data should not be allowed. So for example, there's another malware that is having some crazy things at v99 stored there somehow. The hacker can manipulate that, and then when you access that, then whoa, then you will have some hacker thing in your program. To protect your program from this sort of vulnerability, you try to read an element in an index that doesn't exist. Then Rust will stop and then refuse to continue. So it's kind of protecting you from accessing something that you don't know what it is. Error point is where we attempt to access the index. We can set the, so this, like, if we set the backtrace to 1, to get a backtrace of what's happened exactly. A list of all the functions that have been called to get to that point. Yeah, so in Python, I think the backtrace is there by default, so you will see them all of the time, which is sometimes very confusing and scary. But in Rust, if you want to see that, you have to set the environment variable to 1. You will see. So you're setting it to anything except 0, then you will have everything like this. Ooh. The backtrace is shown. Yeah, so Rust begin to unwind, so you go back to where it came from. There's the panic format, and go back, panic bound, go back to slice index. So this is probably what we are trying to do, and then go back. So there's some implementation for that, and I go back. It's doing some indexing thing, and I go back. Is what we have done. So yeah, so if you go back, then you see like this is the point I got panic, and then trace it back to where it came from. Then we'll eventually see what we have done. But you can see what's happening in between as well. So because sometimes it's not obvious because, well, if you have written any of these code, then yeah, you may want to see what's going on. But this is not us, so it's fine. There's a lot of output. Is also how it got formatted maybe different depending on your also like maybe some low level thing is different depending on your operating system and Rust version. Debug symbol must be enabled. Debug symbols are enabled by default when using cargo build or cargo run before the release flag, because cargo build and cargo run basically we use it for testing, right, before you release. So the debug symbol is already on, but using the release won't. In the output, line 6 points to a line if a project causing the problem. Yeah, so we see here, this is what we have done wrong. If we don't want our program to panic, we should start our investigation at the location points by very first line mentioning our file. So yeah, this is the first line out of these that this is our code. So we should look at this. When your code panic in the future, you need to figure out what action this code is taking and what value it costs to panic, and what the code should do instead. So yeah, see how we can fix it. Yeah, we'll come back to panic when we should and should not use panic to handle error. To panic or not to panic session. Okay, so let's move on. We'll get to that later. Most errors aren't serious enough to require the program to stop entirely. Sometimes when a function fails, it is for a reason that you can easily interpret and respond to. For example, if you try to open a file and the operation fails because the file doesn't exist, you may want to create a file instead, and instead of terminating the process. For example, if you want to write something to a file that is append to the end. So if the file exists, you append something to the end. But if it doesn't exist, you probably want to create an empty file and then start writing there. So yeah, so we are going to do that. Handling potential failure with result. So we remember result is an enum, is okay and error. T and E are generic type. Okay, we will discuss them in chapter 10. T represent the type of the value that will be returned. So OK will return the value. E will have an error. So E is the type of error. We can use the result type and a function defined on it in a different situation where successful value and error value we want to return may differ. So let's see how we use it. So for example, we have the file, so it's in the standard library fs. So main get a file result equals to file opened hello.txt. So so the return type of the file open is a result. So this will be a result. So we can probably use a match later, like that, right? So so there are different types. So E is the standard IO error. May success and return a file handle. So it's either have a file handle that is the type standard fs file, or we have an error with standard IO error. Yeah, the file may not exist, or we don't have permission to open it. So if file open success, then the value will be an instance of OK that contains the file handler, that thing. When it fails, then the value will be an instance of error that have the kind of error inside it. So we have to do a match. That's why. So if it's okay, then we have a file, then we return the file. If it's an error, then we panic and say that, oh, problem opening the file, and then print out the error. Like the option enum, the result enum is the variants have been brought into scope by the prelude, so we don't need to specify result. So result is already a thing. So yeah, so we can use OK and error, no problem. For OK and error variant in the match arm, so yeah, that's what we do. And let's see, if it's not there, we would have panic add. So this is the error message that we brought in. Problem opening a file. So not found, no such file or directory. Matching on different errors. So you can also have different errors. So this one, we're expecting the error to be like the problem file. Yeah, problem creating a file, so it will give you the code to kind of found no such file directory. But if it's something else that is not the error that we're expecting, for example, yeah, error.kind. So if it's not found error, then here we would try to create a file. So when we create a file, we will also have two things, right? If we have the file, we return the file. The file will be returned here, and then will returned here, and then it will returned here, and it will be the greeting file as well. Yeah, this is a little bit complicated. So if we have an error, so we check the kind. So if it's not found error, then we would do this. We would try creating a file. If it's okay, then it will return the file to here, and it will return to back to here. But if it's still, then you can't create a file, then you would panic. But if you have another error, so you would not try to create a file, but just like say that we have a problem opening the file. So this is what it is, and yeah, this looks a little bit like, you know, difficult, but I think when you see this, that it returns, and then you try to find the last assign, which is here, then you would get this back. Yeah, panic is straightforward, it's just panic. Right. So, or like, for example, like me, then I'm like not sure, then maybe I'll just write things separately. I don't know. There's a lot of match. The match expression is very useful, but very much, yeah, it's very difficult to see if you have many matches. Chapter 13, you will learn about closures. Yeah, that will help us a little bit to decipher that. Which are used with many of the methods defined in result. This method can be more concise when using match handling result. Another way to write the same logic is to use closure and unwrap or else method. So this one will open the file unwrap or else error. This is also not very good to look at, isn't it? Yeah, we just haven't learned this yet. So there will be an error, if error kind, if else. Yeah, so I guess like we take the error and then use an if else here. Yeah. Have the same behavior. It doesn't contain any match expression and it's cleaner to read. You sure? Come back to this example. Yeah, I think it may be easier to read when we understand chapter 13. And look up the unwrap or else method in the standard library. Okay, maybe we'll come back later. Make a mental note of that. Okay, so shortcut for panic on error: unwrap and accept. Yeah. So the unwrap method is a shortcut method implemented just like match expression. Result value is the OK variant, and unwrap will return the result inside OK. If result is an error, unwrap will call the panic macro for us. So it's a shorthand, so it will make things easier. So if we do dot unwrap, so if it's error, it will just panic the error, which is what we have written here in the second arm. Here in the second arm. Well, if it's the OK, then this whole thing will just return OK. So, yep. then expect method, just let's choose the panic, so we can also choose the panic error message. Yeah, we've used this before, right, in the greeting, no, the guessing game. We use expect in the same way as unwrap to return the handle or to call the panic macro. The error message used by expect is then called the panic, will be the parameter. Yeah, so we just have a custom message if we use expect. It's the only difference. Yeah, so people probably would like expect because then you can have a custom message rather than generic one, so it's easier to see exactly where it went wrong. So propagating errors. So there are a lot of errors. Right. So now I wrap it in a function. This function will also give you a result. So we try to open the file. If it opens, we have the file. If not, then we'll return the error to here. So this result will have the exact same error instance with the same error. If not, we have the files at the username file. So we create a new string, and then we can read the file, read to string, and then this one is also a result. So it will be either okay. That is just okay. So it's okay. Oh, so it will return an okay with the username because we have written it into username. So we'll read this file and then put it in the username. So if it's okay, so this read to string will give you an empty okay, but then we want to return something meaningful back. So we'll be okay, but with the username inside. This is what we're trying to do here. If an error, again, just relay the error. I guess match. Yeah, so we just relay the error, and it'll probably return the error. Yeah. That's like propagating the error, as if we don't have enough error. Yeah, that's what it does, I think. Right. What about the question mark? What do they talk about the question mark? Yeah. Crash the program. This pattern of propagating error is so common that Rust provides a question mark operator to make it easier. So how does it use question mark to help? So, okay, so file open question mark means that if it's error, then just relay the error. If it's fine, then you just put it here. So again, if it's problem, if there's a problem, propagate it back and probably stop there as well. If not, then it will go to OK and then username. Right. So instead of match and then like return the error, it will just use the question mark. So question mark means that if there's an error, just propagate the error. And if it's okay, just continue. Yeah, so you eliminate the boilerplate and make these functions implementation simpler. Even shorten this code further by writing it in one line. or maybe 2 lines. So first, create a username, and then you can combine all of these. So this question mark here, it will already give it an error. If it's an error, if not, then the whole thing will become the file name, and then it will continue, and here, or maybe 3 lines, and then return the okay username. Right. This is cool. I like the syntactic sugars. Right, so what do we want to do now? So we still have a question mark at the end of this call. We'll still return an OK value containing the username. Both is again the same. Yeah. Make this even shorter. Read to string. What? What? fs read to string is a fairly common operation, so we don't have to write this ourselves. We can just the standard library provided convenient read to string functions that open a file. So yeah, we don't have to reinvent the wheel. So if we just call the read to string function, then it will just read to string. You don't even need this, right? You can just, write this. Okay. A long way first. Yeah, it's like me, baby step, baby step. Where the question mark operator can be used, this one we have a problem because we don't have anything to return, right? Or what's the problem? Opening a file, it may fail. The question mark operators follow the result value returned by file open. But this main function has return type of so it doesn't return a result. So this is not good, right? Because it will question mark will just return it, but we don't have any result type like here to return, so we can't. In the functions that return a result, option, or any other type that implement from residue, you have two choices. You can change the return type of your function to be compatible. Is to use a match method to handle result. So question mark can be used with option, as with using question mark with result. Can you only use question mark on option in the functions that return an options to behavior. So for example, this one. So next line, this one could have a none or have something. So we can use, when we return an option, we can use the question mark. This function returns option character because it's possible that there's a character there, but it's also possible that there isn't. So the code take the text string slice argument and call the lines method, and then return an iterator, and then this function want to examine the first line, so call next. So you can just call next on an iterator. That's good to know. That's something that I should have learned yesterday. So if text is empty, then call next will return none, right? So in that case, question mark will return the none because it's an option. If text is not an empty string, return some value, then we would have it in the slice. A question mark extracts the string slice, and then we call characters on that string slice to get the iterator. We're interested in the last character of the first line, so we will get the last. This is option because it's possible that the first line is an empty string. Last character on this first line. The question mark operator in the middle gives us a concise way to express this logic, because so if it starts with a blank line but the has the character on the other line, so enter hi. However, if there's a last character on the first line, it will be returned in somewhere in the question mark operator. So logic allows us to implement the function. We couldn't use the question mark operator on option. So note that you can use the question mark operator on a result in the functions that return result, and you can use the question mark operator on the option in functions that return options. But you can't mix and match. So either question mark for result or question mark for option. In those cases, you can use the OK method on result or OK OR method on option to do the conversion explicitly. The main function is special because it's the entry and exit point of the program. Restriction of what return type. So we can't change the main return type to something like that, right? Oh, you can. So there are restrictions, but results are allowed. Okay, so we can do that. And then we have to also return OK. So it's either the question mark gives you an error, or you have this back and then you just say OK. This will now compiled. I guess this result is also used for like if you check whether the program execute or not, you have like 0 or 1, right? So you can, yeah. So I think that's why the main can also have a result. The box type is a trail object. We'll talk about that later. Any kind of error. So box means any kind of error. Using question mark on a result value in the main function. Error type is allowed because it allows any error value to be returned. So yeah, that's why we use box here. So any error is fine. Continue to be correct even if more code will return more error. So it would accept any error. Yeah. No, I'm just surprised that they didn't show you how to use the OK method or OK OR. I wish they do. It's fine. Main function return a result. The execute will exit with a value of 0. Yep, 0 if it's OK. If it's 1, then there's an error. Non-zero if it's an error. Yep. So C also do the same thing. That's why it's kind of a common thing. Also return integer from executable to be compatible with this convention. The main function may return the type, implement termination trail. Contain function reports that return an exit code. So yeah, we haven't learned termination yet, but that's something you could use to return something to the main function. Right, panic over. Now we need to think to panic or not to panic. So yeah, let's finish this, and then I'm gonna have lunch and do stuff that I have to do in the afternoon. So how do you decide? Do you want to panic or just return result? You can call panic whenever. So it's just that whether you want to give the caller of your code a option to handle the error, or just they don't have an option, they just have to stop. Prototype code tests are more appropriate to panic instead of a result, because if you have some problem, you may want to look at it immediately. Explore why. Okay. Failure is impossible, but you as a human can. Discuss situation in which compiler can't tell if the yeah. So sometimes like failure only appears in runtime, and then if you panic, then you can go there and debug. When you're writing an example to illustrate some concept, error handling code that can make example less clear. Unwrap that could panic is means that a placeholder for the way you want your application to handle errors. which can differ based on what the rest of the code is doing. Unwrap and expect method are very handy when prototyping. Before you are ready to decide how to handle error, they leave clear markers in your code when you're ready to make your program to be more robust. So you can change it later for unwrap or expect to just return an error or something like that. If a method call fall in the test, you want the whole test to fail. Panic is how a test is marked as a failure. Yeah, exactly what should happen. Appropriate to call unwrap or expect when you have some other logic that ensure the result will have an okay value, but the logic isn't something compiler understand. You have a result value that you need to handle. Whatever operation you're calling still has the possibility to fail in general, even though it's logically impossible in your particular situation. If you can ensure by manually inspecting the code that you never have an error variant. Document the reason why you never have an error variant. Here's an example. So, home IP address, of course, .parse, .expect handle IP address should be valid. So this one kind of safeguarded. It should be valid because you're not expecting it to fail. We see that it's a valid IP address is acceptable to use expect here. However, having a hard-coded valid string doesn't change the return type of the parse method. We will still get a result value. And the compiler will still make us handle the result as if it's error variance possible. Yeah, because it's hard-coded, right? It's probably never going to fail. If it's failed, you probably already fixed it. But because the parse generally would give you result or result as a type, so you can just use expect to handle it. The error variant, it will just panic. That's fine. It should never be panic anyway. See, the string is always a valid IP address. If the IP address string come from a user, then have a possibility of failure, then we won't handle the result. Promise to change the, so if later if we want to change that into a user input, then we want to change the expect to something different to handle the error properly. Guideline for error handling. So have your code panic when it's possible that your code would end up in a bad state. A bad state is some assumption, guarantee, contract, or invariant has been broken. So invalid values, contradictory values, missing values, or passing to your code that are passed to your code. Plus one or more of the following. The bad state is something that is unexpected as opposed to something that will likely happen occasionally. Like a user entering data in the wrong format. Yeah, so if it's a wrong format, you could ask the user to do it again, or you can just stop because there's no point moving forward. Your code after this point needs to rely on not being in this bad state rather than checking for the problem at every step. So yeah, if it's something that fails, then it's probably nothing ever will work, then you probably just gave up early. That's easier. That's not a good way to encode this information in the type to use. We would work through the example, so we'll see it later. Chapter 17, encoding state and behaviors type. Yeah, so for example, you get something, there's no way you're gonna convert it into the type you need, then maybe not continuing. Someone calls your code and passes in a value that doesn't make sense. It's best to return an error. If you so user of the library can decide what they want to do. However, if continuing could be insecure or harmful, then maybe code panic and alert the person using your library about the bug so they can fix it. Panic is often appropriate if you're calling an external code that is out of your control and it returns an invalid state that you have no way of fixing. So yeah, that's better for debugging than handling it. I guess like panic if like for most of the hard coded things is things are predictable, then if something goes wrong it's probably a bug, then you just panic and go and fix it. I think result is more for like when you have some dynamic things, maybe your code is used by another library or a user input, then you can give some control to, for example, the user to re-enter, or the whoever is calling your code to handle the error. Unless something go really wrong. When failure is expected, it's more appropriate to failure is expected, something that is out of your control. Then you can use return a result to make a panic rather than panic. A parser being given a malformed data or an HTTP request returning a status that indicate you have hit a rare limit. Giving a result, then for example a rare limit, you can give a result back to the caller whether they want to stop or they want to retry after pushback or something. Like, it's up to them. When you could perform an operation that could put a user at risk, if it's calling a invalid value, your code should verify the values are valid first and panic if the values aren't valid. This is mostly for safety reason. Attempting to operate invalid data can expose your code to vulnerabilities. This is the main reason the standard library will call panic if you attempt to be out of bound memory access, because that's a security issue. So the standard library will panic you if you try to do the invalid indexing. Try to access memory that doesn't belong to the current data structure is a common security problem. So it's when security is in concern, panic. Functions often have contracts. Their behavior is only guaranteed if the input meets particular requirements. Panic when the contract is violated makes sense. So for example, if you clearly state that I'm expecting you to give me an integer, if you give me anything else, then I'll just panic because, well, you break the rules and I'm not going to continue. But if it's say like, oh, it could be an integer, may or may not exist, and think that, then it's another story. Panic when the contract is violated makes, okay. And then a caller side bug is not something that you should handle, or in fact there's no responsible way of calling codes to recover. The calling programmer need to fix the code. When a violation will cause a panic should be explained in the API. If you documented it, I will only take an integer, then I think people expect that if it's not an integer, then you get a panic and a bug need to be fixed. So everything should be in API documentation. Communication is important. However, having lots of errors checking in, all of your function would be robust and annoying. You can use Rust type system, type checking them by the compiler to do many of the checks for you. If a function has a particular type of subparameter, you can proceed with your code logic knowing that the compiler has already assured you the valid value. So if for example the integer example, if you state the type, the parameter type should be an integer, then the compiler will already taking care of it for you. Type rather than a option, have something rather than nothing, right? So if it's option, then well, of course you can have none, but if not, then you need to have something. Then your code doesn't have to handle two cases of some and none. And you're only that's why it's like in Python it's something is sometimes it's insane. I have to check none like everywhere, and it's very tedious if it can be none and like here and there, but you're not expecting it. So though trying to pass nothing to your function won't even compile, so your function doesn't have to check for that case at runtime. Another example is using an unsigned integer type like U32. Then it will never be negative, then don't worry about the negative. Creating custom type for validation. So how to use the type system? Okay, guessing game. Remember the guessing game? Useful enhancement to guide the user towards a valid guess and have a different behavior when a user guesses a number that's out of the range. One way to do this is to pass the guess as a I32 instead of only U32 to allow potentially negative numbers. Then add a check for the number beginning in the range. Yeah, so if it's negative, if it's smaller than 1, then yeah, you can do that. If, then print out and then continue, and then just guess again. You're probably wrong already. If expression check whether our value is out of range and tell the user about the problem, and continue to start the iteration of the loop and ask for another guess. We can process between. This is not ideal because we have to explicitly write the test here, right? The if. It was absolutely critical that the program only operate between 1 and 100. Many functions with this requirement, having a check like this in every function would be very tedious and might impact performance as well. So instead, we will create a new type. So the new type is guess, so value is I32, and I'll implement a guess. So if we have a new thing, then we would return a guess, but with the check. So whenever we create a new struct, we would of guess, then we would check the value. If it is out of range, then we would panic. So otherwise, we would just return it and continue. Yeah. So that's that. So yeah, you should also, because now you panic, right? You should say in your API documentation saying that it only accept 1 to 100. Also, this range will validate the contract that guess new is relying on. My panic due to this discussion. Yeah, we should have a documentation indicate that like if it's out of range, it will panic. Okay. Implement a method name value that borrows self, doesn't have any other parameters, and return an I32. This kind of method is sometimes called a getter. Right. It's because its purpose to get some data from the field and return it. This public method is necessary because the value field of guess struct is private. It's important that the value field be private, so code using guess struct is not allowed to set the value. Yeah, otherwise you could set the value to be outside of range. Code outside the module must use the guess new function to create a new instance instead of guess. Ensure there's no way a guess would have a value that doesn't check by the condition. So in this case, you will have to, so because value is not public, so the only way to create a new value is to use new, which will go through the test, and then now you need a getter. So you can create a method called value. So if someone dot value, then well, probably added the bracket, then it will get the value. This is a getter. Yeah, you just return the value. That's it. But then you can't change the value or create a value or anything like that. Rust error handling features are designed to help you write more robust code. And the panic macro signal that your program is in a state that can't handle and let you tell the process to stop instead of trying to process. And also tell the user that something went wrong as well. The result enum use a Rust type system to tell the operation that it may fail, but you can handle it yourself. You need to handle the potential failure. Using panic and result in appropriate situation will make your code more reliable and so you could avoid problems. So now that you have seen the useful way that the standard library uses generic with options and results. Okay, whew, a huge thing. So the next topic, again, it will be very big, is about the generic type and stuff. So I don't know whether I have time today. I can't promise that I would be reading chapter 10 today. Maybe tomorrow morning, hopefully. We'll see. We'll see this evening whether I have time, but I can't guarantee anything. So, but anyway, thank you for reading chapter 9 with me about error handling. It's quite fun. We don't have too much hands-on exercise because it's just error handling, but I am thinking the next one will, so it will take a long time. Remember yesterday, the collections is driving me crazy. But we'll stick with it. We'll try to do more exercise. We will have more struggle, and then after that, then we would learn Rust. Then we will be able to use Rust properly. So I think that's it for me for now. Maybe for today. So again, thank you so much for whoever joining my journey. And I will see you very soon. And again, if you want to buy me a coffee, there's a QR code in the little intermission videos there. Right now, I'm looking for a new role. Anything that you support, I really appreciate it. So that's it for me. I will see you next time. Thank you.